Okay, so ladies and gentlemen, you are all welcome. So don't forget that in today's video we are actually going to look at the general revision. Okay, please, are you with me now? We are starting the class right now. Okay, so ladies and gentlemen, you are welcome. So, and I think if you could remember, I clearly stated that in today's video, we are going to look at the general revision of Biochem 241. So, actually, we are going to strictly going to answer one complete question paper. That is one complete first question paper from Biochem 241. And I know that actually that would really help. And please let me start by asking questions. Are you all hearing me? Do you all hear me? Can you all hear me, please? Okay, so thank you. So I think let me start by sharing one past question paper so that at least we can see clearly the questions, and then after reading the questions, then we will now start following them one after the other. So you see, starting, I think you can all see question one. Can you see the question one? The question one says, using a specific example, briefly highlight the relevance of biochemistry to understanding key concepts in nursing science. So that is the first question. With a specific example, briefly highlight the relevance of biochemistry to understanding key concepts in nursing science. So, ladies and gentlemen, let me start by asking you questions because I want this class to be more of interaction. What do you do as a nurse? You are working in a hospital. So now the first question that I'm going to ask as a nurse, what did you do in the hospital? So that is the first thing that I want you to start addressing. As a nurse, what is your role in hospital? And then from there we will link it with biochemistry. So please start answering. As a nurse, what did you do in a hospital? Please answer this. What did you do in a hospital as a nurse? Write, sorry, answer this question on the comment box. Please, I want us to follow these questions one after the other so that we are going to answer all the questions together. They are very key questions. So, and I think we are going to take a lot of our time today to look at some of these questions from beginning to the end. So, my first question, okay, I care for patients. That is number one. I tend to patients in the hospital as a nurse, administer medication drugs, administer drugs, taking care of patients holistically, administer medications, taking care, okay, we take care of sick people, taking the duty of nurse in the hospital is the general patient care, give holistic care to renal patients. Why is it only renal patients? So I think, ladies and gentlemen, I will now give you a key word or a key point of the relevance of biochemistry in nursing. Because here, when we said nursing, it means like in a general medical perspectives. What are the role of biochemistry in the area of medical sciences or in nursing? Like, for example, treatment and diagnosing patients' illness. So, we are now going to see how you can use the knowledge of biochemistry in disease diagnosis as well as the drug development. So, that is what we are going to look at, ladies and gentlemen. So let me start by answering the question. So number one, let me stop here so that you can clearly see what I'm going to write here. So one, biochemistry is used in drug development. One, biochemistry is used in development or drugs development. So now you see from the questions, the question says with a clear example or with a specific example. So we are now going to see how biochemistry can play a role in drug development. So I think it's simple. How do we apply the knowledge of biochemistry in drug development? So that is why it is very, very important to understand the concept of enzymology in biochemistry, which is one of the content of Biochem 241. So what are enzymes? Enzymes are biological catalysts. Enzymes are biological catalysts that speed the rate of chemical reaction. Enzymes are biological catalysts that speed. Enzymes are biological catalysts that speeds the rates of chemical reactions. So that is one of the major roles of enzymes. So we are now going to look at how we are now going to see how you can use enzymes in drug development and disease diagnosis. So we are going to give a specific example. So one of the role of biochemistry in nursing is drug development. So how do you apply the knowledge of biochemistry in drug development? You must know the knowledge of enzymes. So what are enzymes? Enzymes are biological catalysts that speed the rate of biological reactions. And what they do, normally as an enzyme, they have what you call an active site. So let's say this is an enzyme. So the enzymes have an active site where the substrate, so here we have two things. Number one, we have, this is an enzyme. This is what we call an enzyme. This is an enzyme. And this is the enzyme active site. This is the enzyme active site, ladies and gentlemen. Enzymes active sites. So what is enzymes active site? Is a region of the enzymes where the substrate binds. And what is a substrate? A substrate is a molecule that binds to the active sites of the enzymes for catalysis to take place. So this is a substrate. So we have a substrate here. So we have an enzyme and we have a substrate. So what happens? The substrate binds to the enzyme. The substrate first. You see here we have the substrate bind to the active site. So here we have what we call enzyme substrate complex. Let's get this point, ladies and gentlemen, because it is very important. We have an enzyme. This is an enzyme, and in the enzyme there is an active site. And what is the role of this active site? Is a region where the substrate binds for catalysis to take place. So now we see we have the substrate here and it binds to the enzymes. So when the enzymes bind to the substrate, it forms what we call enzyme substrate complex. And there are three steps. So this is the step one, where the enzymes plus substrate combined, and then finally you will have your free enzyme. And then you have your final product. You have your final product. So at the end, after you have enzymes plus substrate, it will produce enzyme substrate complex. And then after the reactions, then you are now going to have your free enzyme, enzymes, and then you have your products. A product is the final product. Oh, sorry, a product is what produced at the end after the reaction. So now, how do we use these enzymes in drug development? So I'm now going to give a specific example. We have what we call a cyclooxygenase pathway, a typical example of one of the pathways. So you see, a cyclooxygenase pathway is one of the pathway where arachidonic acid is converted into prostaglandins. Prostaglandins. These prostaglandins can be prostaglandins 1, can be prostaglandins 2, and can be prostaglandin 3. And these prostaglandins, they are molecules produced by the body that causes headache. They causes headache in humans. They causes inflammation. So there is an enzyme called cyclooxygenase. So a cyclooxygenase is an enzyme that convert arachidonic acid to prostaglandins. And these prostaglandins are the molecules that usually produce in our body under stress. So you see, ladies and gentlemen, I want to say something here very important. You know that when we are under stress, we usually come up with headache. So how do we come up with that headache? So actually, ladies and gentlemen, arachidonic acid is an acid that usually found in, remember, actually in a cell membrane. In our cell membrane is made up of, or is highly rich with phospholipids. So, ladies and gentlemen, as I said, it's highly rich with what? Phospholipids. So our cell membrane is highly rich with phospholipids. So under stress condition, these phospholipids, when we are stressed, an enzyme called phospholipase A2 will be activated, ladies and gentlemen. Look at it very well. When we are stressed, an enzyme called phospholipase A2 will be activated. And once this phospholipase A2 is activated, when we are under stress, this phospholipase A2, you see, let me come here and we have phospholipids, ladies and gentlemen. So when we are under stress, a phospholipase A2 is activated. Please, ladies and gentlemen, all this explanation that I'm giving is very, very important, because by the time you miss all this explanation, that is where you are going to start having problem with your examination. So I'm all giving this because at the end I'm going to give you a final answer. But I'm trying to give all this explanation because this is part of what we have discussed in the course. So we have phospholipids. So when we are under stress, an enzyme called phospholipase A2 will be activated. And the major role of this phospholipase A2 is to remove fatty acid at carbon 2. So when these enzymes act on phospholipid, it will produce what we call lysophospholipids plus arachidonic acid. So you see, when we are under stress, a phospholipase A2 enzymes will be activated. And once it is activated, it will convert phospholipids into lysophospholipid and arachidonic acids. And this arachidonic acid, it is actually a 20 carbon fatty acid that has 4 double bonds. It has 4 double bonds. So it's a 20 carbon fatty acid that has 4 double bonds at different carbons. So once this arachidonic acid is produced, so this arachidonic acid will now undergo cyclooxygenase pathway where the arachidonic acids, look at it, where the arachidonic acids will be converted into prostaglandins using an enzyme called cyclooxygenase enzyme. So once the cyclooxygenase convert arachidonic acid into prostaglandins, then it will now cause headache. It will now cause headache. Do you understand? It will now cause what? Headache. Please get it, ladies and gentlemen, very well. It will cause headache. So once it causes headache, that is where we are going to start feeling the pain of headache. So, but now, ladies and gentlemen, how did we stop this headache in our body? So we have what we call inhibitor, we have what we call inhibitors. What are inhibitors? Ladies and gentlemen, when we say inhibitors are molecules that block the activity, of an enzyme. Please, ladies and gentlemen, get it very well. What is an inhibitors? They are molecules that block the activity of enzyme. So it means that they are molecules that can stop the activity of a particular enzyme. So that is why now, ladies and gentlemen, assuming now you get a molecule that can inhibit the activity, that can block the block the activity of cyclooxygenase inhibitor, that can block the activity of cyclooxygenase. Do you think, let me ask you these questions, ladies and gentlemen. Do you think doing this, blocking the activity of cyclooxygenase, can prevent prostaglandins production? The answer is yes. So if prostaglandins cannot be produced in our body, are we going to have headache and inflammation? That is the question. I'm solving 2019 past question paper. I am solving 2019 past question paper. So do you think that after blocking the activity of cyclooxygenase using a particular inhibitor, do you think that it can block or it can prevent headache? The answer is yes. And ladies and gentlemen, let me tell you this. The aspirin, that is the paracetamol that we use to prevent headache or to cure headache, is the inhibitor of cyclooxygenase enzyme. So when we are taking paracetamol, when we take paracetamol to prevent headache, so where that paracetamol work, it works by inhibiting the activity of cyclooxygenase. So this is the pathway or the mechanisms of action of aspirin. And I think this is part of what we are going to discuss. So aspirin is a drug that block the activity of cyclooxygenase. So by blocking the activity of cyclooxygenase, it means that arachidonic acid cannot be converted into prostaglandins, and these will now prevent headache and inflammation in our body. I hope, ladies and gentlemen, this is clear now and understand. I hope you are now clear and understand how aspirin block or inhibit the activity of cyclooxygenase. So one of the applications of biochemistry in medical sciences is drug development. With a specific example, an aspirin is a drug that block the cyclooxygenase activity, which prevent arachidonic acids from converting to prostaglandins. So this is how it works. And let me give another example because it's part of the questions that we are also going to answer next. Still on that drugs development, because from this past question paper, there is one question that asks the mechanisms of action of aspirin. So I have already answered this. So when we come to the questions, I will directly refer you to here. Excellent, excellent. Is it Novaren? Yeah. Let's take for antibiotics. So, ladies and gentlemen, let's take antibiotics. And antibiotics is a drugs that kills microorganisms. So let me just give examples of one antibiotics: penicillin, penicillin, penicillin. Part of what we are going to do, ladies and gentlemen, you are going to do medical microbiology in your second semester. And I have all the videos here on my YouTube channel. That is why I always encourage you to go and subscribe and join the YouTube community so that you will have access to all my videos. So now, ladies and gentlemen, in bacteria, they have what we call cell wall. Cell wall. And what is the importance of cell wall in bacteria? Its importance of cell wall in bacteria, number one, it provides structural support and shape of the bacteria So one of the major role of the cell wall in bacteria is provide structural support and shape of the bacteria, and it prevents, number two, it prevents uh, the bacterial cells from external attack. So what I'm trying to say here is there is a cell wall in bacteria, and the importance of this cell wall in bacteria is like a structure that found in the bacteria that prevent it from any external attack. It's like a wall in the bacteria that trying to protect the bacteria from any organisms or anything that can damage the bacterial cell. And one very important thing that make up this cell wall is peptidoglycan. Peptidoglycan. So in the cell wall of bacteria, they have glycoproteins, and this glycoproteins is called peptidoglycan. Glycoprotein called peptidoglycan, which found in the cell wall of the bacteria. So, ladies and gentlemen, I want to tell you something in terms of the architecture of the cell wall of bacteria. If there is no peptidoglycan, then there will be no cell wall. And if there is no cell wall in the bacteria will die. The bacteria will instantly die. It will die. So most of the antibiotics in the bacteria, what they do is that they blocks or they prevent the production of peptidoglycan. So therefore there will be no cell wall. So the microorganisms can easily recognized by our immune system and they will die. So that is what I want us to understand here, ladies and gentlemen. So I hope now you understand. No peptidoglycan, no cell wall, bacteria will die. So now, how did we produce this peptidoglycan? One of the pathway of peptidoglycan pathway is there is a step where amino acids, amino acids, and some carbohydrates, carbohydrates join together to produce what we call the peptidoglycan layer, peptido, peptidoglycan. So there is what we call a there is an enzyme called transpeptidase. Transpeptidase. There is one of the important enzymes called transpeptidase. Transpeptidase is one of the enzymes that combats some of the amino acids, or let me just say actually polymerization, polymerization of glycan, or polymerization of glycoproteins. So for the polymerization of glycoproteins here, because there are some amino acids that join with the glycoproteins to produce peptidoglycans using transpeptidase enzyme. So it means that this transpeptidase activity is where this glycoprotein joins with some amino acids, to produce peptidoglycan. So it means that if you can get an inhibitor, that is a molecule that can prevent the formation of this peptidoglycan. So if peptidoglycan cannot be produced by blocking the activity of transpeptidase, it means that there will be no cell wall formation. Then the bacteria will die. So these inhibitors, usually they are penicillin. Most of the antibiotics, they are either derivatives of penicillin. So that is how penicillin works. Penicillin works by inhibiting the activity of transpeptidase enzymes, which prevent the formation of peptidoglycan, and therefore, as a result of this, there will be no formation of the cell wall in the bacteria. Therefore, the bacteria will die. Ladies and gentlemen, I hope. Okay, so someone is asking question: what happens, sir, when there is a resistance to the antibiotics? So I want to say something, ladies and gentlemen, very important. Is it Agano? He asks questions that now I think you now understand. Inhibitor, especially penicillin, is a compound that inhibits transpeptidase activity. And if transpeptidase activity is blocked, it means that there will be no peptidoglycan formation. And if peptidoglycan cannot be formed, there will be no cell wall formation, and then the bacteria will die. So now someone is asking a question. Peptidoglycan. Yes, the spelling is this. Peptidoglycan. This is the spelling. So now, someone is asking a question: what happens in a situation where there is a resistance to antibiotics? So, ladies and gentlemen, I want to tell you something. In the penicillin, they have the active ingredient. The most active ingredient in penicillin is called beta-lactam ring. That is the active component of the penicillin. The active component of penicillin is called what? Beta-lactam ring. These antibiotics called penicillin, they have a very important component in them. This important component that found in them is called beta-lactam ring. So it is this beta-lactam ring that interact with transpeptidase enzymes and block its activity. So please simplify it for me. I'm getting confused because of scientific grammars. There is no any scientific grammar. Someone is asking, what is transpeptidase? It's an enzyme that produces peptidoglycan. So if you get a molecule that can stop the functions of this transpeptidase, so there will be no peptidoglycan formation. And if peptidoglycan cannot be produced, it means that the cell wall of bacteria cannot be produced. So if the cell wall of the bacteria cannot be produced, then the bacteria can easily die. The bacteria will die. So if the bacteria die, what happened? It means that the penicillin is active. So now someone asks question that how is it that after you produce antibiotics, after 2 years, 3 years, 10 years, it will not longer be active, meaning that the bacteria are now become resistant to that antibiotics. So someone is asking how that happened. So the answer is simple. The answer is simple. In the penicillin is having the active component in it, and that active component is called beta-lactam ring. So when this microorganism they realize that they are dying, they are killed by penicillin through this beta-lactam ring, then through evolution, they will now develop a mechanism that will now make the penicillin inactive. How they do it? They produce an enzymes naturally in them because they are wise. They also want to survive as we as human. If they realize that something is killing them, something is causing their death, they will try to develop a mechanism. They will try to develop a mechanism that will protect them from dying. So how they do that? They will now start producing enzymes in them. The microorganisms will start producing enzymes in them called lactamase. Called lactamase enzyme. Called what? The name of the enzyme is called lactamase. The microorganism will produce an enzyme called lactamase. These lactamase enzymes will now start degrading. It will now start destroying the beta-lactam ring of penicillin. So once you take the penicillin, the microorganisms already have, or the bacteria already have lactamase in them. They produce lactamase. Therefore, they will now inactivate the beta-lactam ring in the penicillin. So therefore, the penicillin cannot work. So that is how the microorganisms work. The first scientist that discovered this penicillin is accidental, is Alexander Fleming. Alexander Fleming. When did he produce this? Okay, someone is saying that we can't get the writing clearly, so I will increase the handwriting. I will increase the handwriting. Okay. So as I said, the microorganism will produce beta-lactamase. It will produce lactamase. That is the name of the enzyme, lactamase. And this lactamase will now destroy the beta-lactam ring. in the penicillin. Therefore, the penicillin will now become inactive. So the scientist that produced the first penicillin is Alexandra Fleming in the year 1941, and later on in the year 1944, the penicillin become inactive. By making, how does it become inactive is through resistance. So how this microorganism become resistant to penicillin is by producing lactamase, and the lactamase inactivate beta lactam. So this is how microorganism develop resistance to antibiotics. So, ladies and gentlemen, I think this is very clear. So, one of the role of nursing in biochemistry is, sorry, one of the application of biochemistry in nursing is drug development. And from here, I clearly demonstrate how you can produce how you can produce antibiotics like penicillin by inhibiting transpeptidase enzymes. Please, ladies and gentlemen, yes, that is why sometimes, because as a scientist, as the microorganism develop beta lactamase, then you will also think of another way to develop another drugs that doesn't have beta lactam ring, maybe another like ampicillin. That is why we have different varieties of penicillin. We have ampicillin. We have many others. Why? Is because if you realize that microorganisms become inactive or become resistant to a particular group of insecticide or class of insecticide, then scientists will think of developing new one. So as you produce new one, they will still also develop resistance to it because they are always trying to survive as human. Sometimes they even cap the active site. Alexandra Fleming Fleming. This is the name, Alexandra Fleming. Is it success? Yes, Alexandra Fleming. So now, ladies and gentlemen, that is one of the application of biochemistry in nursing. So another application of biochemistry in nursing is disease diagnosis. I hope now you are now clear with this. Yes. Are you clear with this? Drug development, how biochemistry play a role in drug development by developing an inhibitors of a specific enzymes. Like for example, penicillin is an antibiotic that block transpeptidase activity. And aspirin is a drugs that prevent headache by inhibiting the activity of cyclooxygenase enzyme. So now the next thing that we are going to look at is application of biochemistry in disease diagnosis. In disease diagnosis. So another application of biochemistry, you can use the knowledge of biochemistry in disease diagnosis. Disease diagnosis. Disease diagnosis. Okay, that is disease testing. Assuming now you have a patient suffering for a particular disease and you want to check what happened to that particular person. Is he having a problem with a particular organ or a problem with a particular disease? Is it HIV? Thank you, sir. My question is, how does HIV virus survive all the antibiotics and antivirus drugs? Yeah, I'm actually coming to that because if I now said I will be asking most of these questions, we might not actually going to answer most of these questions from the question paper. But of course, the answer is through the resistance. And we should know that, assuming that you have an antibiotics like penicillin, so you ask yourself question that, okay, are the virus having cell one? They don't have cell one. They don't produce peptidoglycan. So they don't have transpeptidase enzymes. So that is why antibiotics cannot kill virus. Antibacterial drugs cannot be antiviral drugs because it depends on the target. Even if they have peptidase enzyme, that is transpeptidase enzyme, but the transpeptidase enzymes in virus, is it the same with the bacteria? No. So there is a specificity. So most of the drugs that are produced, they are specific. Sometimes some drugs that are meant for antibacterial cannot serve as cannot serve as antifungal, cannot serve as antihelminths. So there are specificity because drugs are produced based on the enzymes. Based on the enzymes. Okay, you should get that. So in disease diagnosis, ladies and gentlemen, let me take urea. Urea. What is a urea? A urea is a waste product of ammonia. So what happens, ladies and gentlemen? We know that we take protein. When we eat, we take protein. And this protein will be digested into amino acid. Look at it, ladies and gentlemen. Protein will be digested into amino acids. And then this amino acid through the carboxylation reaction, through oxidative decarboxylation, also through oxidative deamination will produce keto acids. It will produce keto acid plus ammonia. Let me just say amino group. Amino group. Or you can decide to say ammonia. Let me write it in bracket, ammonia. So ladies and gentlemen, when we eat proteins, it usually produces keto acid and amino acid or ammonia. And this ammonia that we are saying is toxic in our body. We don't need it. We don't need it. We don't need this ammonia in our body. In fact, if ammonia is highly, or when you have an increased ammonia in our body, it causes mental disorders. In fact, it causes convulsion, it's called seizure, it causes coma. Sometimes if you have patient in hospital and you realize that they are suffering with mental disorder, it may be as a result of colossal accumulation of this ammonia. If you have someone in coma, in convulsion, it may be as a result of this increased of ammonia in the body. So ammonia is one of the end product of protein digestion. So when we digest proteins, there is a likelihood that we are going to produce ammonia. And we don't need that ammonia in our body. We have to excrete it. Leaving it in our body, it causes inflammation, it causes edema. It causes our brain to inflame. It causes mental disorder. So we don't need this ammonia. So how do we do it? So ladies and gentlemen, the only way to remove that ammonia from our body is by converting it to urea. So therefore, this amino converted to urea. It will be converted to urea, and the process in which ammonia is converted into urea is called urea cycle. And where is this urea formation take place in our body? Where is this urea cycle take place in our body? It takes place in the liver. It takes place in the liver. It takes place in the liver. Please get it, ladies and gentlemen. All this explanation is very clear, and take your time and understand what we mean. So ammonia is waste product in our body, and we don't need it in our body. We need to excrete it. And how do we excrete this ammonia? Is converting it into urea. And where this urea formation takes place in our body, it takes place in the liver. So when you produce urea in the liver, how did you excrete it? You excrete it through our kidney, through our kidney. So you see, ladies and gentlemen, from here, I want to tell you something. Using this urea as a molecule, you can know the status of your liver. You can know the status of your kidney. Whether your liver is having any health challenges or whether your kidney is having any health problem. But how? How? So normally in our body we have a range of this ammonia in our of this urea in our blood. Naturally, we have urea in our blood. We have urea in our blood. We have it, and it has its normal range. It has its normal range. Yes, I'm not yet actually finished, so we are still on it. So we have a normal range in the urea. So, but now the question is, let's say, I'm just assuming, let's say the normal range of urea in the blood, let's say is 135. Let's say it's 135 milligram per deciliter. Let's say this is the normal value of urea. I'm not saying that it's exactly the normal range or the normal value, but it's usually found in the blood. And what I want you to understand, ladies and gentlemen, if you now, let's say, the normal value of blood urea, let's say, is 135 milligram per deciliter. So now I want to ask you a question. Assuming now, instead of as a hospital or as a nurse, you pick blood sample from a particular individual, or you take urine sample, and you now realize that in the blood sample you have, let's say, 380 milligram per deciliter of urea. Let's say you check this in the blood, and this is the normal range. So now, ladies and gentlemen, I want to ask you a question. Between the liver and the kidney, which one do you think it has 135 milligram per deciliter in the blood? I'm just assuming because it's not exactly the normal range, but I'm just giving an assumption for you to understand. Let's say this is what you're supposed to have as the urea in your blood. And then you now take the blood and you test for urea. And then you observe that you have, instead of 135, it's now increased, it now shoot up to 380 milligram per deciliter. Please, I want you to ask me, excellent, excellent, excellent. Is it JC Nasi? The JC Nasi said the answer is kidney. The problem, it means that the problem is from kidney. But now the question is, why do you think the problem is from kidney? Why not liver? Why not liver? That is the question. Why not liver? Why kidney? It's supposed to be 135 milligram per deciliter, and you now observe 380 milligram per deciliter. So where do you think the problem is? Is it the liver or kidney? But the nurses say kidney, and I agree, and the answer is perfect. So now the issue is that most of you that are seeing that you are not seeing the what? It's an indication that maybe it is you that are having problem of network. So now the question is, why do you think it's kidney? Why kidney? I agree the answer is kidney. But why kidney? Please, I need the answer on the comment section. Please, I encourage you. In this of my YouTube channel, there are videos on human physiology 227 biochemistry and biostatistics. So, okay, excellent, Clara. Clara Igulo, she said that the normal range, because this is just an assumption, she said the normal range is 2.5 to 7.1. 6.5 to 7.1 millimoles. Millimoles per liter. So this is the normal range in the blood. That is the urea. This is how it's supposed to be. So let's say now you take blood sample and after you check, you now observe that the urea is 20 millimoles per liter. So why do you think the problem is? Because it shoot up? Yes, I agree. The problem, because in some scenario, the problem is from kidney. But why the answer is kidney? Kidney is not able to eliminate the excess urea. Excellent. It means that the liver is doing its function, it is producing enough of the urea, but the kidney, because it's having problem in terms of the filtration, so it cannot excrete the urea. That is why it shoot up. So now, let's say instead of 2.5 to 7.5, and then now you check the blood and you observe that there is a decrease in urea, let's say you find out that it's 1.1 millimole per liter. So you now observe that it's 1.1 millimole per liter. So where do you think the problem is? Is it from the liver or the problem is from the kidney? The liver has done its job, yes, by producing it, but the kidney that are supposed to excrete rather store it instead of excreting. Excellent. So now, which one do you think is having problem when it goes down? Instead of 2.5 to 7.1, and now you after checking the blood, you now observe that it's 1.1 millimole per liter. Are they solar? Yes, the answer no. At this point, the answer is liver. It's liver, not kidney. It means that the liver is producing, sorry, is not producing the urea. It's not producing the urea. So that is why it is lower than expected. So I hope, ladies and gentlemen, you now understand how you can use the knowledge of biochemistry. This is part of what you are going to do in Biochem 242 in the next 1 month or 1.5 months in Biochem 242. That is why I always encourage you, ladies and gentlemen, join this YouTube channel. You need it for your BNS nursing. The the videos on biochemistry, the nutrition, the physiology, and the microbiology that you are going to do are all here. So I hope you now understand how you can apply the knowledge of biochemistry in disease diagnosis. So I think from the questions, let me see how many questions are we to actually, what is the question clearly so that we can know that, you see, using a specific example, briefly highlight the relevance of biochemistry to understanding key concepts in nursing science. So I think we give two examples here and it's clear and I think you understand. So you can apply the knowledge of biochemistry in disease diagnosis, you can apply the knowledge of biochemistry in drug development. And I think with these two examples, ladies and gentlemen, I think it is really clear. So do you understand? So that we can move to question 1B. Can we move to question 1B? So now question 1B. Question 1b says the ABO blood group system is related to some glycoproteins. Discuss. Yes. So, ladies and gentlemen, I want to start with this. The ABO blood group system is one of the genetic inheritance that we can inherit it from our parent. And we have basically 4 types of blood group. We have blood group A, we have blood group B, we have blood group AB, and we have blood group O. Blood group A, blood group AB, blood group O, and then blood group AB. So these are the 4 types of blood groups that we have. So in this case, we are now going to look at the different glycoproteins that are found in these different blood group types. So I want you to tell me this, ladies and gentlemen, what is the name of the sugar that found? What is the name of the sugar that is found in an individual with blood group A? So we have blood group A, blood group B, blood group AB, and then blood group O. So what is the name of sugar found in blood group A, the name of sugar found in blood group B, AB, and O? What is the name of the sugar that found in an individual with blood group A? And what is the name of the sugar that found in blood group B? What is the name of sugar that found in blood group AB? And then the name of the sugar that found in blood group O. That is what I am asking. Please tell me the name of sugar found in an individual with blood group AB. No, it's not glycogen. It's not glucagon. No. Please, I need answer for this. What is the name of sugar found in an individual with blood group A, with blood group B, and then AB? Okay, someone said N-acetyl galactosamine. Okay, so you see, an individual blood group A and B, they have a glycoproteins. And in the surface of the glycoproteins and the glycolipid of an individual with blood group A, they have a monosaccharide excellent called N-acetyl galactosamine. So an individual with blood group A has N-acetyl galactosamine on the surface of their glycoproteins. That is why, okay, ladies and gentlemen, generally, all individuals with blood group B, they all have, with blood groups, they all have glycoproteins and glycolipids. They all have glycoproteins and glycolipids. But what make the blood groups differ from one another is that an individual with blood group A on their glycoproteins, they have N-acetyl galactosamine. That is why they are blood group A individual and make them different from those with blood group B. So for those with blood group B, they have galactose. That is the name of the sugar that found on an individual with blood group B. And then an individual with blood group AB, it means that it has both N acetyl galactosamine and galactose. So it means that an individual with blood group A, it has N-acetyl galactosamine, and then an individual blood group B have galactose. AB, it has N-acetyl galactosamine and galactose, and then an individual blood group B has none of the sugar. Is that clear now? Ladies and gentlemen, is that clear? Is that clear? Please look at the sugars very well. Look at the sugars very okay. So, ladies and gentlemen, the question now, do we inherit blood groups? Yeah, but I think you can hear me now. Do we inherit blood groups? Okay. Yes, we. Okay, so Seru is actually a network issue, so let's continue. So you see, you answered that yes, it is correct, or it's possible to inherit your blood groups. So now, let's look at it. So if you have someone, why did we inherit blood groups? If you have N-acetyl galactosamine on the surface of your glycoproteins, so it means that you have blood group A. And why is it that you have blood group A? Is because you inherit an enzymes from your parent called called glycosyl transferase A. So because you have glycosyl transferase A as an enzyme, that is why these enzymes usually added the N-acetyl galactosamine on the surface of the glycogen of your red blood cells, and that is where you have blood group A. And then a situation where you have an enzyme called glycosyl transferase B. It's an enzyme, it is an enzyme that add galactose on the surface of your red blood cell, and that is why you have blood group B. Then for a child that have both of these enzymes, it means that these two enzymes can add both N-acetyl galactosamine and galactose. And then for someone with blood group B, it means that he doesn't have if you don't have any of these two enzymes, glycosyl transferase A and B, it means that none of the sugar will be added, and that is why you are going to have blood group O. So this is how we inherited blood group types. So if you have blood group A, it's because you have these enzymes. And this enzyme is a protein that we can inherit it from our parent. So if you have transferase A, it means that you have this sugar added by transferase A. If you have glycosyl transferase B, it means that galactose will be added on the surface of your glycogen. And if you have blood groups, so if you have glycosyl transferase A and B, it means that you are going to inherit blood group AB from your parent, indicating that you have both N-acetyl galactosamine and galactose. And if you have blood group O, it means that you have none of these two enzymes. So that is actually the answer for this. So first, if you are going to answer this, what we are going to do, you start with saying that, okay, an individual are having different blood group types based on the sugars that are found on the surface of the glycoproteins. So then you start, an individual blood group A has a monosaccharide called N-acetylgalactosamine, an individual blood group B has a galactose. So ladies and gentlemen, this is the answer to the okay, the name of the enzymes is glycosyl transferase A and glycosyl transferase B. That is the name of the two enzymes. So ladies and gentlemen, I think we now answered question 1B. So let's look at the other questions. So then question 1A, 1B, so we are now moving to question C. That is one sequentially list and describe the 6 classes of enzymes. The 6 classes of enzymes. So that is the next question. The 6 classes of enzyme. We describe them. So how do we list and describe the 6 classes of enzyme? So we are now going to list them. So I think, ladies and gentlemen, from the beginning of this class, I gave you the definition of an enzymes. I said that enzymes are biological catalysts that speed the rate of chemical reaction. So generally, there are reactions in our body that they can take years, that they can take months for them to. So, ladies and gentlemen, I want to say something here very important. Please, if you know that you are not a member to my YouTube channel, I encourage you. Like, for example, tomorrow we are going to solve questions on biostatistics. So if you are not a member, you might not even be able to join this YouTube. So I encourage you to try and join the YouTube membership. For this of your first semester, I'm taking you 4 courses. Human Physiology 225, Human Physiology 227, then Biostatistics and Biochemistry. But for biochemistry, most of the videos are free. But for biostatistics and human physiology, the 2 human physiology courses, you have to join as a member. You have to join as a member. How can you join as a member? You have to use your ATM to make payments. To make payments. And you are going to have access to all my videos. You are going to have access to all my videos. And I'm telling you, if you watch all my videos, especially for these courses, I don't think you are going to have problem with any exam. The most important thing is keep watching them. So for those that are not members, if you see, like for example, look at Lucia Chidiluto, she is a member. That is why you see her name is not the way, the color of her name is not the same as those that are not member. Okay, you see, look at Gloria Otubo Gloria. Thank you, sir. But please throw more light on how we inherit blood groups. So you see, in the case where we have Otubo Gloria, she's a member. So that is why look at her name. Look at Sally Etim. She is also a member. So if you are not a member to my YouTube channel, I encourage you to register with the YouTube membership so that you can have access to all my videos. And very importantly, I also want to tell you something. If you register as a member, you are going to do second semester courses, and they are all present in this YouTube. So if you register, you will have access to all those videos. It's just 1,500. So what you are going to do, use your ATM. When you go to my YouTube channel, you will see join. So click on that join, and you are to impute your ATM details, those numbers. So you input them, you put the expiry date, you put the CVC number. So once you add them, you click join, then you will join as a member. So if you do that, you will not have problem. You will have access to all my videos. Yeah, but look at you, look at you. It's you are already a member. You said, is it Obi? Is it Obiru? Say Mary Fiuma. I paid yesterday, but I'm not seeing my name. Yeah, your name is here. Look at name Afia with different color. So that is why it means that you are a member. So if you are not a member, please try to join the YouTube membership so that you can have access to all my videos. You can have access to both the first semester courses and second semester courses. And you also have access to 300 and 400 level courses. So I encourage you to do that. Try to do that. No, it's monthly. It's 1,500. So you'll have access. So I upload videos almost every day. So like for example, I almost complete videos on biostatistics. And if you are not a member, you cannot watch the video. In fact, you can just go and check my playlist. Sir, okay, please are the classes of enzymes. Yes, I will mention them. It's simple. Just use ortholil. I usually use this simple formula, ortholil. We want to write the name of the enzymes, ortholil. So these are the 6 classes of enzyme. No, if you register RODA, if you register the YouTube membership, is a monthly payment, and you can cancel it at any time that you want. Yes, the money cover for all the videos, the money will cover all. Once you make that payment, you'll have access to all the videos. Yes, it's only using ATM. You can only pay using ATM. Okay, I will increase the screen. So that is the answer. The 6 classes of enzymes. These are the 6 classes of enzymes. These are the 6 classes of enzyme. Ortholin. Some of you will start saying how. So ortholin. Let's start. O means of Z do re doc tase. Oxidoreductase. That is the first one, oxidoreductase. And what is the description? Because it's not about the list. After you list it, you list, and then you will now start the function. So oxido, from the word oxidoreductase, it means it catalyzes enzyme that catalyzes redox reaction. That is a reduction or oxidation that catalyzes oxi, oxidation and reduction reaction. So it catalyzes oxidation and reduction reaction. That is why it calls oxidoreductase. And then the next one after oxidoreductase is of the T. The T here means transferase. It is an enzyme that catalyzes transferase, an enzyme that catalyzes transfer of a group. Transfer of a group. Like for example, let's say you have ATP and you have plus glucose. So when you take one of the phosphate from ATP and you transfer it to this glucose, it is going to be glucose 6 phosphate. So it means that you take one phosphate and you add it to carbon 6 of glucose. So that is why you have glucose 6 phosphate. So it transfers it. Then the next one is H, which is hydrolase. Hydrolase enzyme. That is the next one. Hydrolase, that is the next enzyme. Hydrolase enzyme. What does it do? It catalyzes hydrolysis. Hydrolysis of a bond by adding small molecules like water. It catalyzes hydrolysis, that is breaking down. Hydrolysis of a bond, that's breaking down of bond by adding smaller molecules or small molecules like water. Then the next one is L, which is ligase. Ligase. When you say ligase, it means joining. Ligase, that is the next one. Ligase enzyme. Joining. When you have two smaller molecules, so you join them together. Two molecules. When you have two molecules and then you join them together to give you one molecule, and that is why we call it ligase. Ligase. Then after L, that is the first L, then the next one is I. The I, look at it here, the I here stands for isomerase. It catalyzes isomerization reaction. Then the last one is lyase. It catalyzes lysis, that is breaking down. What am I going to zoom in? It's clear. O, oxidoreductase, T, transferase, H, hydrolase, L, ligase, which is clearly written here. Ligase joining two molecules together to produce larger one. I, isomerase, and then the last one is lyase, breaking down. So these are the 6 classes of enzymes with their description. So we list them and we describe them. So this is actually for question 1C. This is for question 1C. So now we are moving to question 1D. Question 1D. Okay, isomerase. The catalyzes isomerization reaction. What is isomerization? That is to change one functional group to another functional group. Maybe You have a compound that have ketone functional group, and then you change it from ketone functional group maybe to aldehyde functional group. So that is isomerization. Yes, that is the sequential. You use ethylene. Ethylene. Yes, of course, if you want to join and you don't have card, you can use any other person card to join. But I'm encouraging you, don't look at the money seriously. If you are thinking that you'll be looking at the money, I have over 500 members in the YouTube and none is having any issue. So you can join today, and if you don't want, you can decide to cancel it tomorrow. That is what I want you to understand. But I'm telling you, you know that actually for most of you, you know that a lot of people are benefiting, and I'm happy with the YouTube. So it's better you join. So now, I think we now finish with listing and describing. So the next thing that we are going to look at is what is the relevance of B vitamins and their derivatives for catalytic reaction in our body systems. Biochemistry questions are very tough. Are you sure, Joshua Daniel? So now the next question is, what is the relevance of B vitamins, that is by vitamin B, and the derivatives in to the catalytic reactions in our body? Okay, so let's now answer question 1D. Question 1D. The importance of vitamin B and their derivatives in catalytic reactions in our body. You see, all these things that I am doing, I have already finished them on my video on YouTube. So you can follow all the videos one by one. You can get all the answers from there. You can get all the answers from there. So now, they are not tough. They are not tough. Just keep reading. So, enzymes, we are going back to the enzymes again. I have a video on the enzymes, so I think I advise you to go and watch them. I think I sent you some videos last time. So, what are enzymes? So, actually, we have what you call APO enzyme. APO enzyme. Yes. We have what you call APO enzyme. Or sometimes you can call them zymogen. This is called inactive enzyme. You can call them either alpha enzymes or zymogen. Thank you very much, sir, for joining. Thank you very much, sir, from Pakistan. Thank you very much, sir, for joining. So we have alpha enzyme for zymogen, which is inactive enzyme. And for these enzymes to be active, they need what you call coenzymes. Some of these enzymes, they need what you call coenzymes for them to become active enzymes. And the active enzyme is called holoenzyme. It's called holoenzyme. It's called holoenzyme. So the holo enzyme is called the active enzyme. So you see, zymogen or alpha enzyme is called inactive enzyme. So for these inactive enzymes to be active, you need a coenzyme. And what are those coenzymes? Most of them, they are vitamins. Most of those coenzymes are vitamins. So we have like vitamin B. And some of these vitamin B, we have like niacin. And it's this part of niacin that produce NADH and NADP, NADPH, NADPH, and we also have NADH. We also have thymine. This thymine is can be TPP. So what are the role of vitamins? Vitamins are micronutrients that are required by the enzymes for them to be active. That is the answer. That is the answer. Okay. Thank you very much for that. I know all this very well, sir. Okay. Thank you very much. The medical world. So thank you. IBN is also Bachelor of Nursing student. So thank you for joining from Pakistan. So I'm saying that we have alpha enzymes or zymogen, which is inactive enzyme. And for these enzymes to be active, they require coenzymes. And what are those coenzymes? Are mostly vitamins B. Examples of these vitamins and their derivatives, we have niacin, and it's from this niacin that we can get NADH and NADPH. We have thymine, which can also have the TPP, that is thymine pyrophosphate. So these are the coenzymes that are required by the enzymes for them to be active into holo enzymes, which can be used for catalysis. So it means that these are the role of enzymes in the role of vitamins in catalytic reaction. Vitamins are coenzymes. This is how you put it. Vitamins are coenzymes that are required by the enzymes for them to be active. Examples of these vitamins include niacin, thymine. Some of the examples of enzymes that require these coenzymes, like for example, the TPP. The TPP require these enzymes. So the TPP is required by enzymes like alpha keto glutarate dehydrogenase enzyme. Another enzyme that requires this thymine or TPP, we have pyruvate dehydrogenase complex. So these are some of the vitamins. They are coenzymes that are required by the enzymes for them to be active. Sir, I'm lost. Is it possible to list the V vitamins and their derivatives to catalytic reactions beside them? Yeah, of course, that is why I said we have like thymine. Thymine is a component of TPP. So TPP is thymine pyrophosphate. Thymine pyrophosphate is one of the example of coenzymes that require by alpha-ketoglutarate dehydrogenase enzyme and pyruvate dehydrogenase enzymes complex for them to work. So I just gave example of thymine. And of course, for the NADH, you can even have uh, for the NADH, you can also have malate dehydrogenase enzyme. For NADPH, you have malic enzyme. So these are some of the coenzymes that are required by the alpha enzymes for them to be active. Why did you lost? The question says describe the role of vitamins and their derivatives in enzymes or in catalytic reaction. So their role is that the vitamins are coenzymes and they are required by the alpha enzymes for them to be active enzymes. And the active enzymes is odo enzyme. So when you have inactive enzymes, alpha enzyme plus coenzymes, that will give you odo enzyme. Alpha enzymes, they are molecules required by alpha enzymes for them to be active. And examples of the coenzymes that are required by the enzymes, we have vitamin B. Okay, welcome Yusuf Remoka. So you see one person just joined. That is why I'm telling you, try to join. Try to join. Try to join. Like if you didn't join now, after this video, it's only those that are member that can still have access to these videos. So we are encouraging you to try as much as possible to join and watch. So now, the coenzymes, example of these coenzymes that are required by the enzymes, we have vitamins. And some of these vitamins, we have niacin is a vitamin. Thiamine is also a vitamin. So what are the examples of coenzymes that are produced by niacin? We have NADH and NADPH. Examples of the NADH enzyme, or an example of enzyme that require NADH, we have malate dehydrogenase. Another example of enzyme that require NADPH is malic acids. Another examples of enzymes that require thymine pyrophosphate is alpha ketoglutarate dehydrogenase and pyruvate dehydrogenase complex. So that is just the answer. Okay. So I think, ladies and gentlemen, we are done completely with question one. And I think it took us, look at it, you can see that it took us 1 hour 43 minutes. So I'm just actually trying to give explanation so that at least anytime when you see similar questions, you can easily address them. You can easily address them. So I think because it is actually getting late and I'm in school since morning, I don't think maybe we are going to stop here. Wow. Excellent. So look at another one. Fatima Kingi Sadiq. Fatima, but I'm advising you if you are joining, try to join the level 2. PQ and short videos. That is where most of your first semester videos are. You see, Fatima, okay, Falmata joined, but she joined level 1. Yes, if you are my student, of course, the videos will be free. And don't forget, tomorrow we are going to do biostatistic. Tomorrow we are going to do biostatistic. And most of these questions that I'm answering is not part of the job that I'm doing for DLC. Because I think there is no any lecturer that can do that. Sir, which level did I join? Yusuf Remark. Yeah, I think for the tomorrow biostatistic, I think we are going to make it. Let's try to make it around 11 a.m. I don't want to stay late. Yeah. So maybe because tomorrow we need to actually calculate, or maybe you can make it four. Yeah, we can make it four. Yeah. Yeah, Yusuf Remark, I can't see your level now, but if you can watch all my video on biostatistics and physiology, it means that you are at level two. No, I didn't drop quiz. I didn't drop it. Yeah, you can try it again. Fatima Baba. But for the biostatistic, if you know that I'm not taking you, so for the biostatistic, you have to join. Yeah, we are still going to use my YouTube. Thank you for all your effort and sacrifice, and God bless you more. Thank you very much, Chima. Thank you very much for also appreciating what I'm doing. Yes. Hi. It's not easy, seriously. Allah is not easy. Hey. Of course, we are going to stop here. We are going to stop here. So, yeah, but I'm advising you, if you are not a member, try to join. If you are not a member, try to join, especially for the tomorrow's biostatistic. Because after biostatistic, we are also coming to your physiology courses. So, we are going to answer them all. So, thank you very much. And I think I'm going to stop here. Yes, let's make the biostatistic by 4 p.m. By 4 p.m. tomorrow. Yeah, I can send you the question paper. I will send you on WhatsApp. I will send you the question paper on WhatsApp. But you will see that we just only answer. And I think we are going to be answering this question paper. Maybe will be, maybe I think we are going to make it maybe if possible every day. So you see another, is it Guinness Wellness and Beauty Stores? Just join. So that is how it is. Try to join it now so that at least when you pass these exams, it is you that will be happy. Yes, you can join the level two. Go back there and check the level two. It will show you upgrade. So you click on that. So maybe what we are going to do, because it is already time for the exam. So I think we'll think on how to be answering the question. Like for example, tomorrow we'll do by statistic. Next tomorrow, maybe on Saturday, we'll do physiology 225. The problem is that I don't want to. You see, since morning I'm here in the university, so I didn't go home. So I don't want my family to be complaining. Yes. Okay, so no problem. I will send you the link to join. Thank you, sir, for the wonderful lecture. Yeah, no problem. So I think if you start answering some of these questions, I'm serious. I'm very happy. I'm telling you, you'll not have issues. And in many cases, most of the questions that you are going to see, they might not be difficult as this. So that is why you see that most of the students that I took last year, they are very happy with both the biostatistics and biochemistry, is because we are following things gradually and the way it's supposed to be. So that is why maybe we need to have a similar video on biochemistry, like 5 more videos. Yes, let's start going home. So thank you very much. And if you didn't join to the YouTube, I'm going to send it to the WhatsApp group. So thank you and see you next. Bye bye.